This is a quick intro to partBuilder for Lockheed, just to give you an expectation on what to expect when you're trying to build parts for AllegroHdl and Mentor at the same time. The first thing we're going to do is we're going to set an environment variable, and it's going to point to this directory called Customer Site Settings Lockheed, and here is where we store all the settings that are specific to you guys. Right here. So typically you'll do this on a shared drive that any of your librarians can get to. And what we do here is this is where we store how you build your parts. So all the rules that build your parts. So I'm going to set that up, and then I'm going to start partBuilder. And if we look at the beginning, we can see that we opened up the site setting Lockheed files, and if I click on some of those links, it'll pop up and show us what the settings are. Now, of course, I've made these up for what you guys are doing. Typically we work together at the beginning of the project to get those set up. So now we're going to just do a quick overview. So if you guys watch the intro video, partBuilder is built into a couple steps. It does pin extract, where it's going to read this spreadsheet. And this spreadsheet, in this case, is set up to be the simple TQFP format. If we edit that one, we're going to take a quick peek at it. And this is a new format that we've added to support like some spreadsheets that look like this that you get from Analog Devices, is one of the vendors. So partBuilder can read this and say, okay, switch 0 is pin 1, TG0 is pin 2, and it can walk around this whole thing and find all the pins for you, and even find the center pin as a ground. So now we use pin extract to read that file, and it comes up and it tells us it found 53 pins. Now the next step, sometimes in a spreadsheet like the TQFP, there is no pin types. So what we have to do is go into Pin Explorer and define pin types. Now partBuilder automatically finds the power and ground pins based on pin name matches, and then it also can assign types based on just if it didn't see a valid type, it'll assign BIDR, and then we can go and let's say vSense 1 and 2 are input. These are inputs, so we can assign a pin type to an input. The BGs, let's see, boost 1 is boost, and boost 1 is another input, let's say, assign pin type input. So we use the Pin Explorer to assign pin types. So we edit these pin types using that simple format of right click, assign pin type, whatever. And then what happens is when we're done, we save it into this pin type override file. The next time we pin extract, it'll read all the parts, and then it'll look for a pin type override file and assign them. The better job we do with pin type assignments, first of all, the first benefit is you get a better part with valid pin types. The second benefit you get is the next step in this process is SmartFrac, and SmartFrac is going to try to assign these pins to symbols right out of the gate for us. And it's going to sort inputs on the left, outputs on the right. It's going to fit bidirectional pins as best it can on the symbol, and then it'll group the power pins together. So getting a good pin type override file is important. So here you can see we said, okay, we change vout config and vout1. We're going to save it as to be input pins, and we'll save and close. So again, the next step is SmartFrac, and SmartFrac is going to sort your pins, like we said, by input, output, bidirectional, and power pins, and it's going to build a symbol description language file. Okay, when we start, we don't have a symbol description language file. When we run SmartFrac, it's going to look through all our pins. It's going to find buses. It's going to find inputs, outputs, power pins, and it's going to sort them into the best possible symbol that it can build just right out of the gate. So if I hit SmartFrac and run, it built this SDL from template.sdl. If I run SDL map, it's going to map the pins in this SDL to symbols. And look, it says it's found the symbol name all signal pins and all power pins, and then it assigned 53 pins to symbols. The SDL map mapped them to symbols. Straight out of the gate, we get symbols. We run the symbol builder, it's going to build whatever set of symbols that we assign, the AllegroHdl, the OrCAD, and the DX Designer in this case. And we can take a look with the View Symbols button at what it built for us. We got a set of 2 symbols with the signal pins and the power pins. Okay. SmartFrac designed those for us, and now if we don't like them, we can use the STL editor to go make some fixes. This is saying the STL file was auto-generated. We need a new name, so we'll say OK, and we'll call it test1.stl. This is what our STL file looks like, and it's good to show that at the same time as the symbol that it created. So we can see, number 1, it started a symbol here and it ended it there at line 34. The first symbol was named all signal pins. The second symbol was named all power pins. Well, this is a pretty small part. Do we really need 2 symbols? We don't have to. What we could do is delete this end of symbol and delete this start of symbol. And then we could put this balanced symbol sides in here and separate the power pins by, let's say, 3 grids. We could save this as, let's call it test2.stl. So now we'll get a completely different set of symbols. We're going to say yes here, and then we can go and build and view symbols one more time. And we can see now it built 1 symbol with all the pins together. And if I wanted to change the name of the symbol, I could say all pins and save that as test2, and then run it just one more time. Build and view symbols. So you can see it's re-entrant. It builds the symbols really fast, and then we can zoom in on them and take a look. This is the very cool HTML viewer of the symbols. You get an HTML view so you can share the symbols with anybody just by zipping up this one directory, and they don't even need partBuilder to look at your symbols. You could search for pins, the alert pin, it'll find it. You could search by pin number. Let's find pin 52, and it'll jump right to the pin 52. Let's find pin 24, and you can see it's an intelligent search. So, and when you type 2, it's going to show you all the pin name. In this case, the pin numbers with a 2 in it. Let's jump to pin 26 and search for that. Here is the origin, which is programmable. The origin can be here, can be here. We can set it up in your site file to be wherever you want. When you click the origin, it shows you the properties that are attached to it. Okay, and if you click a pin, it's going to show you the properties that are attached to those pins. If we want, let's take a quick peek. So that was the AllegroHdl. Let's look at the Mentor symbol. And here we can go in and zoom around. Again, we have our properties, we have our pin properties. So we're going to have to get together and work with a template symbol of yours so we can find out how you guys typically build your Mentor symbols and assign the properties for it. So let's go cover that for a second. So if we want, in here we can move pins around very easily. We can see the alert pin is on the right, the A select pin is on the right. We placed a bus here, A select 1 to 0, the BG pins 1 to 0. There's a fault with some asterisks after it, so partBuilder or SmartFrac does the right thing to build that match. And so what happens is this symbol description language, this is a pin match, and partBuilder goes, okay, is there any pins matching boost? I'm going to put them on the left. Any pins matching boost 1? I'm going to put them right under it on the left. And so on, and it goes all the way down. Here's the pins that are on the right. This balanced symbol sides puts a new section in the symbol. So we got to P good on the right, 1 to 0. We said balanced symbol sides, so it said, okay, well, let me start a whole new section here, and we'll start with the NC pins. So what if we want the NC pins, what if we want to move those to the bottom where they go? So we can either cut it and paste it, and put another balance symbol sides in there. I can copy that to separate them. And now the NC pins will be on the left and the bottom if we run it. That says we changed it. And here you can see the NC pins and the power pins are here. So that's a quick way of just dancing around in the SDL editor to create your symbols. Now, the interesting thing for you guys is I talked with Nolan a little bit, and he was saying, well, how do you know what part properties are? We have this part property editor. And so for each tool we can set up the properties that are on that tool. So for AllegroHdl, these are the properties that we add, and they're all controlled up here. For DX Designer, these are the properties we have. Again, I didn't know what you guys add to your DX Designer symbols, so this is just a quick shot. If we want to add more properties, we add them in here. The nice thing is we talked initially about the site file. Where we really store these is in your site file, so that when you start up the tool, everybody gets the same symbol props for DX Designer and for AllegroHdl. Part of what happens is you also get this locator, so this tells you where the refdes property is. So the refdes property is on the top. It's offset by 100. It's not visible, so we can turn it to visible or not. The part number is not visible, we can turn it, and the symbol name we can turn to visible. We can change the size, we can change the justification. When we save those changes, we'll save them to your site file, and you'll always be building your parts the same way. So again, so SDL map step takes the pins, it uses the SDL, and it finds all the pins and it assigns them to symbols. The symbol builder is the special step, and it does its own thing for AllegroHdl, it does its own thing for OrCAD Capture, and it does its own thing for DX Designer. So that's how we can build the proper symbols for each tool. So again, a very quick 1,000-foot level intro into what to expect when you're building parts with partBuilder. And we can cover this in more detail whenever you like.